All right, in this video, we are going to work through the following problem. It says determine if the described lines are the same line, parallel lines, intersecting, or skew lines. If intersecting, give the point of intersection. All right, we have these two lines, L1 and L2. L1 is 201 plus t times the vector 64 minus 2. L2 is the vector 410 plus t times the vector negative 3, negative 2, 1. Okay. All right, so we're just going to do exactly what we did before. We're going to write these in terms of the parametric equations, right? So looking at line L1 and just translating this into the parametric version, we have 2 plus t times 6, so 2 plus 6t. We have y equals 0 plus t times 4, so that's going to be 4t. And we have z is going to be equal to 1 plus negative 2t. So 1 minus 2t. And we're going to do the same thing for, let's see, just lagging a little bit. We're going to do the same thing for the other line. Though we are going to use the parameter s, right, for that, because when we need to try to solve for this intersection point, we can't use the parameter, the same parameter twice for these sets of equations. All right, so this one's going to be x equals 4 plus s times negative 3, so 4 minus 3s. Y is going to be equal to 1 plus s times negative 2, so 1 minus 2s, and z is going to be equal to 0 plus s times 1, so z equals s. Okay. All right, so next up, before we move forward though, let's take a look and at these direction vectors and just see if they are parallel or not. So looking at this vector here, the direction vector for line 1, I have a 6 is the first component, a negative 3 is the first component for the second direction vector. So that would be a negative 1/2. 6 times negative 1/2 is negative 3. 4 times negative 1/2 is negative 2. Negative 2 times negative 1/2 is positive 1. So these two direction vectors are in fact parallel to each other. And so that means that of the four possibilities, these two lines are either going to be the same line or they're going to be parallel. We know that much, okay? All right, so we're going to continue to try and solve this out. Remember, if these lines intersect, the x and y, the point at which they intersect, the x, y, and z values would have to be exactly the same. So that leads us to this system of equations, right? 2 plus 6t equals 4 minus 3s. We have that 4t equals 1 minus 2s. And we have that 1 minus 2t would have to be equal to s. Okay. And then we would just try to solve this system right here. So we would pick one of the equations and solve for either s or t. I am going to choose this one right here because it is already solved for s. So that is pretty easy. I don't really have to do anything. And now I would just go to one of these other equations and substitute in the 1 minus 2t for s. Okay, so I'm going to go ahead and do that up here. All right, and I am going to go with the second equation. So I have 4 times t equals 1 minus 2, and then s is 1 minus 2t. All right, and then I'm going to solve that equation. So I have 1 minus, distributing that negative 2, I have negative 2 plus 4t, and 4t negative 1 plus 4t. All right, then I'm going to get everything with a t on one side by subtracting 4t from both sides. And I get 0 equals -1, right? So that is a false statement, and so therefore there is no solution to this. Okay, the intersection, right, of these two lines, there's no solution to this 2 by 2. So therefore there can't be a solution to the entire system, right? There's no pair of values for the variables s and t that will simultaneously make this equation and this equation true. So there's no way there could be such values for all three equations right here. So what we knew from looking at the direction vectors, since they were parallel to each other, that meant these two lines were either the same line or they were parallel to each other. And so since there are no solution, there are no points in common between these two lines are parallel. Okay, and that is it on this one. I did graph these out, and so you can see, right, that's what they will look like. If I can get that, yeah, there we go. That's a good picture of it. All right, and that is it on this particular problem.